All right, so here's our scoring for number 4, part A. We'll see how we did. Let's see. So the correct answer they give here 1/2 25 minus x squared to the negative 1/2 times negative 2x, and that's equal to negative x over square root 25 minus x squared. And the points are rough on this one because we get 2 points for getting f prime of x. Well, f prime of x is the answer. So we get 2 points for our answer, and that's it. There's no partial credit on that, just 2 points. So now let's look what I did. If we look at this, their answer, we can see that one thing I did is I said verbally that I have to multiply this negative 2x, but the way I wrote it, it certainly looks like I'm not multiplying it, I'm supposed to subtract it. So I would probably lose a point for that because there's supposed to be parentheses. However, as it turns out, remember I said you didn't need to do this, you didn't need to simplify it. In my case, I simplified it and I got what I got matches their answer exactly. Now, I spoke to some scorers who said, this is going to count as a recovery point. This is actually wrong and would be marked wrong. But since in my next step I corrected it, I recovered that point. So if I had failed to write this, if I had just stopped here as I told you to, I would have gotten it wrong because I had this mistake here. Now you wouldn't, because you wouldn't make that mistake. You would not forget to put the parentheses around the negative 2x, and then you would have it right here. But I made that mistake, but then I came here and I recovered, so since my answer exactly matches their answer, I get the full 2 points. If I hadn't had this, I would have gotten 0 points. Just for leaving off this parentheses, 0 points on that problem. So I'm glad that I went the extra step and simplified it and recovered my mistake. Let's look at our part B. So on part B, we get 2 points. 1 point is for getting f prime of negative 3, and the other point is for the answer, which means the equation. So where's our f prime of negative 3? Here's f prime of negative 3. I said it was 3/4. What did they say f prime of negative 3 was? They said it was 3/4. So I got that point for saying what f prime of negative 3 was right there. Now I get another point for getting the answer. It says an equation for the tangent line is y equals 4 plus 3/4 x plus 3. Now I've put my 4 on the other side, but my answer is mathematically equivalent to their answer. Therefore, it counts for full points, so I got 1 point there. Now here's an important place that we can talk about how scoring works and how you get or lose points. If I had gotten the derivative wrong, so let's say I did the derivative completely wrong and I got completely the wrong number here. Now I've lost the derivative point, but let's say I came up with 7/8, and if I took that 7/8 and put it right there and had all the rest of this right, I would still get this point for the answer even though my f prime was wrong, because they will grade this answer based on the result that you got. So if you got this wrong, it's not going to cost you this point. So you could, even if you were really lost on this derivative, you could still get this point. One important proviso is that I have been told by scorers that if I do that, if I make a mistake with the derivative and I try to recoup the point from another part of the problem, it's important that whatever I came up with for a derivative is equally complex to the derivative that was actually there. So if I say f prime of x is 2x, and then so I say my slope is -6 and I put that in here, I'm not going to get this point because what I came up with was too simple, and it didn't lead to the kind of work that I needed to do this. So the proviso with the recovery point is that I have to have done something as complex, even if I did it wrong, and then I can still get that point from the next part. So that's part B. It looks like I got full points on part B. Be happy about that. Now let's look at our part C. So on part C, we only have 2 points. Now look at what the 2 points are. Considers one-sided limits. Now, did I consider one-sided limits? Yep, right here I found this one-sided limit. Here I found this one-sided limit, and I showed that they were equal. So out of all this, these right here, that was 1 point. Just to look at this right here, that was 1 point. And then the other point is answer with explanation. Now this was before I looked at the scoring. I thought I would probably get this point even if my explanation was wrong, because I'm correct that g of x is continuous. But the way this is worded, it says answer with explanation. That means if my answer was right, but my explanation was wrong, I don't get the point. So even if I was right about this, my explanation is wrong, I'm not going to get a point here. All my points are coming from my explanation. So was my answer right? It says that g is continuous at x equals -3. So I got that part right, but I need to get the explanation right. And if we look carefully at the explanation, here's our left-sided limits. Here's showing the left-sided limit is 4. I did that. Here's showing the right-sided limit is 4. I did that. Therefore, the limit is equal to 4. I said that. Therefore, the limit is equal to 4. And then they said that g of -3 is equal to f of -3 is equal to 4. I put my f of -3 equals 4 up here. See, g of -3 equals f of -3 equals 4. That's exactly what they wrote. And therefore, limit as x approaches -3 of g of x equals g of -3. That's what I wrote here. And they said, since I said this one is 4 and this one is 4, I can just say they're equal. I said this one is 4, this one is 4. Therefore, since they both equal 4, it's continuous. So I said a little bit more than they said. But it looks like my explanation is a little more involved than theirs. But I hit every point that they were looking for, so I get that answer with explanation point. So that's my answer with its explanation. It's really all of that. So it looks like I got 2 points for part C. Now in part D, we get 2 points for the antiderivative and 1 point for the answer. So by antiderivative, they mean what's in these brackets. And in the brackets, I have that exact expression right here. So right here is my antiderivative. Notice that's 2 points. I have to get all of this completely right, and I get 2 points. There's no way that I can get just 1 point for that. It's all or nothing on that. 2 points for the antiderivative. Then 1 point for the answers. The answer is 125 thirds. I need to match that. It's 125 thirds. Now, if we look carefully at the way they wrote out their work, and we didn't get any points for the way we wrote the work. We only got points for the antiderivative and the answer. But they changed their limits. So remember, I said this was another way we could do this. When we do the substitution, many people will change the limits and say, instead of leaving the limits 0 and 5, when I do my substitution and make it u to the 1/2 du, we can take the 0, the lower limit, plug it into our u substitution, 25 minus x squared, and get 25. And then the upper limit, when I plug in 5 for the upper limit, I get 25 minus 25, that's 0. Now that's how they write their integral, the integral from 25 to 0 of square root u du. So that means that when we get here, you do your antiderivative, and now we have -1/3 times, we had u to the 3/2, but now we're going from 25 to 0. And what this frees me up from doing is, now I don't have to plug the x back in. I can plug the 25 directly into here. So now I can say this is -1/3 times 0 minus 25 to the 3/2. But I still have to deal with -1/3 times negative, and I have to figure out that this is 125, and I get my 125 thirds. So this is an alternative way to go about evaluating this integral using change of limits. That's called change of limits. And that's a fairly common way to do it. I personally often leave the limits the same and then put the x back in. But that's your choice. There you go. That's our question 4. Looks like I got 3 points for that. So I got 3 here, 2 here, 2 here, 2 here. That totals up to 9. We got 9 out of 9 on that one, so we're pretty happy.